Page 3. Page 3, we're going to start off with number 17. An inequality, but this one requires you to graph. The earlier ones didn't require graphing, now they do. 2x plus 3 is greater than or equal to negative 1. 2x plus 3 is greater than or equal to negative 1. It solves just like a regular equation. You've got to solve, get rid of the 3, and it makes 2x is greater than or equal to negative 4. And to solve this, you divide by 2. Divide by 2. Now, this one, even though there's a negative over there, you did not move a negative with multiplication or division over to the other side. So the inequality stays a greater than or equal to sign. It doesn't flip-flop because the negative divided by a positive is still a negative answer, and it's a negative 2. Now you've got to graph this on the number line. And because it's a greater than or equal to sign, it's going to be a closed circle at negative 2. Closed circle means a dot. That means this number, negative 2, could be placed back in for the x, and it would make it a true statement. 2 times negative 2 is negative 4. Negative 4 plus 3 is greater than or equal to the negative 1. That's why that's a closed dot. And it is all numbers greater than. Greater than numbers go to the right on the number line. Greater than. If you look at that, they get bigger, absolute value-wise, to the right. So that means everything's shaded to the right. That's what the graph should look like. Closed circle at negative 2, and everything shaded to the right. Now, the next problem is a couple of inequalities that you've got to solve, but it's an and statement. This is where some of you made an error with this one. Being that it's an and statement, you're going to graph both of the equations on one graph, but the only part that matters is the overlap. So when you have the 3x plus 4 is less than or equal to 13, and the 6 plus 2x is greater than negative 2, you solve both of these equations, just like inequalities, just like equations. Subtract the 4. 3x is less than or equal to 9. This one is x is less than or equal to 3. That's what the first one turns out to be. X is less than or equal to 3. I'll make the number line down here. I'll make 3 over here. It's less than or equal to, so it's a shaded in dot, and it's all numbers less than, and less than on a number line goes to the left. Now the next one, you subtract the 6, that's a negative 8. 2x is greater than negative 8. X is greater than negative 4. So all numbers greater than negative 4. Now it is just a greater than symbol, so it's an open sign at the negative 4. That means negative 4 would not work in this, but it's all numbers greater than. That means that way, so it's everything shaded this way. This is an and statement. This I hate. I despise whoever taught you to graph it like this. This is just a directional area right in here. The graph is this. Everything between these two, but not including the negative 4. It includes the 3. That number will work in both equations. It's an and statement. Because it's an and statement, and that's why it's in all caps, an and statement means it has to work in both of the original equations. If I put a 3 up here, 3 times 3 is 9. 9 plus 4 is 13. Is 13 less than or equal to 13? Yes, it's equal to. It works. If I put the 3 into this one, 2 times 3 is 6. 6 plus 6 is 12. Is 12 greater than negative 2? Yes. This works in both equations. But if I take the negative 4, I put a negative 4 up here. Negative 4 times 2 is negative 8 plus 6 is negative 2. Is negative 2 greater than negative 2? No. Doesn't work. It works in the top one because the negative 4 times 3 is negative 12. Negative 12 and 4 is negative 8. Negative 8 is less than or equal to 13. Works great here. That's why it showed it shaded this way. It would have covered the negative 4, but because it doesn't work in the second equation, it doesn't work in both of them. And we are just looking at where they work for both. Some of you did all the right work, did all the right things, did the right graph, but then left it as this stuff and didn't show where they overlap. Some of you shaded backwards and did it wrong that way. You've got to make sure that you do this correctly within this problem. All right. Number 19. All it's asking you to do in number 19 is write the equation. It doesn't say solve it. Doesn't do anything. All it wants you to do is write the equation. You need to know these are vertical angles. They are equal to each other. That means 4x minus 14 is equal to 3x plus 15. Done. That's what they're asking you to do. Show that those two angles are equal to each other. 4x minus 14 is equal to 3x plus 15. Done. Number 20. Pam has 24 pairs of shoes in her closet. This is 3/4 as many as Bill. Okay? 3/4 as many as Bill. We'll say Bill is X because we don't know what Bill is. And it's equal to Pam's amount of shoes. Pam has 24 pairs of shoes. We know that Pam has 24. We know that Bill's amount of shoes is 3/4 that. Okay? This is 3/4 as many as Bill. That means Pam's is Bill's got a crap ton of shoes. That's what that's telling you. Her 24 shoes is just 3/4 of whatever Bill's is. Bill is a shoe hoarder. He has too many shoes. You only have 2 feet, most of you. Okay, so Bill, you got too many pairs of shoes. Good Lord, you've got a ton of shoes. Some of you figured out the answer. Don't need to. It asks for the equation for how many shoes Bill has. That's it. Same thing here. I don't care how many games that Connor can buy. It wants an equation to show how many games he can buy. Okay, so with this one, it says a game system costs $300 plus $50 per game, 50x. And we need to spend at the very most no more than $600. That's what it wants. Now, some of you wrote some different equations or inequalities that did work out, but you've got to write the inequality that shows Connor's work for this information, which is the $300 game system, $50 a game, can't spend any more than $600. Can spend equal to it, but no more than that. Some of you found out it is whatever, 6 games, 4 games, whatever it is. I don't care. Not asking for that. It's asking for the inequality. Okay? Now, numbers 22 and 23. I'm going to do that just right in here. These are and statements, or statements. And statements, you have to show where they overlap. Or statements, you have to show whatever. It doesn't matter if they overlap. It doesn't matter if they don't. So this one, if I'm going to show this one, x is greater than 5. So if I have my number line, and this is 5, it's just a greater than sign. Ow, oh my gosh, almost went blind there. Okay, it's just a greater than sign, so it's an open dot. Okay, and it's all numbers greater than 5. That's greater than. This one says all numbers less than or equal to 9. Well, over here is 9, and it's a closed dot, but it's all numbers less. I'm done. I just did it right there. It's between 5 and 9. Can't include 5, but it can include 9. It's an and statement. We're looking for the overlap. This one shades this way. This one shades this way. Some of you showed both of them on there, pointing both different ways. I don't care about that. I need to know just what would work for both of them. This is the one that it doesn't matter if you show them on the number line. This one tells you -3. All numbers less than -3. That's an open circle at -3, and it's all numbers less than. That's everything to the left, everything smaller than -3. The other one is x is greater than 1. Well, that's 1, and it's open circle at 1, but it's everything greater. They don't intersect. If this was an and statement, what would your answer be here? There is no answer that works for both of them. There would be no real number or no solution. This wouldn't work. But because it's an or statement, you just put them both on there. It has to work for one of them or both of them, but it just has to work for one of them. So if the answer for this one, let's say my answer that I choose is 0. Does 0 work in this? 0 falls between -3 and 1. Does that work for either of them? No, 0 is not a good answer for this. Okay, so far so good. Last but not least, number 24 on page 3. Y is equal to -3/5 x plus 2. It's an inequality, so it's going to be a solid or dotted line, and you've got to graph this. Some of you don't know the slope-intercept formula. Okay, the slope-intercept formula is this. Y is equal to mx plus b. Either you don't know it or you don't remember it. Okay, slope-intercept. This is the slope, m. This is the intercept, b, where it crosses the y-axis, how my graph moves. It tells me right here, it crosses the y-axis at 2. So I go to my graph, it crosses the y-axis at 2. That's my starting point right there at 2. My slope is -3/5. That means it's a negative slope. That means it's going down from left to right. Down 3, 1, 2, 3. Right 5, 1, 2, 3, 4, 5. Down 3, 1, 2, 3. Right 1, 2, 3, 4, 5. Over here. Now, since I know how to do this, I can go in reverse. Since it's down 3, right 5, I can go up 3, reversed. 1, 2, 3, back 5. Up 3, back 5. And it is just an inequality that is a less than sign. Since it's less than, it has to be a dotted line. With a dotted line in this one, that means the lines that are part of this do not work. Anything that falls on this graph will not work for this problem because it's just the ones that are less than. Now, how do I test to see where it works? I test by using the origin. We know the ordered pair for the origin is 0, 0. I put a 0 in for the x and a 0 in for the y. A 0 in for the y, a 0 in for the x. What's 0 times -3/5? It's 0. What's 0 plus 2? 2. Is 0 less than 2? That's a true statement. That means any point below the line that includes the origin, the one that we found here, any point down here could be placed into this equation and it would work for this specific equation right here, -3/5 x plus 2. We found an unlimited amount of answers here, but they have to fall behind the dotted line. And because we found that 0, 0, the origin does work in the original equation, it does work for this, all those are down here. That's why it says here, is it a solid or dotted line? Solid or dotted line. That's what I found here. I didn't even have to graph it. I didn't have to do anything. Once I looked at this and saw that it was a less than symbol with no equal to sign, done. It's a dotted line. And then don't forget to shade. I will not be that nice to you on tests, okay? I'm not going to say, don't forget to shade. Is it solid or dotted? I'm just going to say graph the inequality and be done with it. All this gobbledygook over here is just them being nice to you. It's a dotted line because it's a less than symbol, and it is shaded below because the origin, when I tested it, go in there. Okay, there's a boatload of problems in this. The solid or dotted line is a point. The shading is a point. You got to do those things right. Some of you graphed incorrectly and graphed it as a positive slope. I know automatically because the slope out in front of the x is a negative number, it should be going down from left to right. If you got an answer that went up from left to right, wah, wah, wah. All right, this is page 3. Page 4 is coming. Bye.